So recently, I've been seeing a lot of smooth tool videos. Those are the guys that make welding applications for the UR robots. They have some pretty cool patterns where you can just put down 2 points on a table and it'll do a weld pattern between those 2 points. I was kind of wondering the other week, how do you think they programmed those? What actions do you think they used to get to that point to make it so easy? And I figured, well, why don't I just try and program it myself? So that's what I did. I ended up coming up with 4 different patterns that possibly could be used for welding. I'm going to show you how I programmed them and kind of the ideology behind their movements.
So this first program I made is just a simple stitch weld. I have waypoint 1 and waypoint 2. The robot is going to move from waypoint 1 to waypoint 2 and move in a back and forth direction until it gets to waypoint 2. So the way I achieve this is I first set my waypoint 1, and then I also set waypoint 2, and then I'm going to loop these directions until I get pretty close to waypoint 2. And the actual function I have going here is I'm looking for the distance from the tool center point to waypoint 2, and I'm looking for it to be less than 1/10 of an inch. That's what these conversions do here, because pose distance outputs meters, so I'm just converting it to 1/10 of an inch. Inside the loop, I'm going to first do a direction towards waypoint 2 for a distance of 0.2 inches. How I find that is I do a post subtract of waypoint 2 to waypoint 1. This is essentially grabbing a vector in the direction from waypoint 1 to waypoint 2. After that, I go back half that distance, so I'm going to go back 1/10 of an inch, and I do the same post subtract but the other way around, so I have a vector going from essentially waypoint 2 to waypoint 1. This variable 1 here can be ignored. This is simply an output for how far away the tool center point is from waypoint 2. So when I run this, I can go to my variables tab and I can watch variable 1 right here and see how far away I am. So after I get 1/10 of an inch away from waypoint 2, it's going to finish the move by going to waypoint 2, and then it's going to wait just for half a second, and I'm going to move up in the Z direction by 3 inches just to clear the say workpiece. So over at the robot now, I'm going to set waypoint 1, and then I'll set waypoint 2. It can be set anywhere, but I'll set it about here. So I moved over in X, Y, and up a little in Z. Now I'm going to play that from the beginning. The next pattern I have is a zigzag. This pattern moves in 2 directions along the axis of the weld. So I first find the direction from start to long as a vector, and then I'm going to make it a unit vector, and then I'm going to scale it by whatever I want. So however long I want each one of these zigzag jumps to be. Then I'm going to repeat a pattern of moves, and I'm going to go start to short, back to start, back to short, and then I'm going to increment those until I get to the long point. Here's the program on the controller. I'm going to start at the bottom and then go back to the top. So I have this move J at the very bottom after a halt that has my start, short, and long points. This move will never actually be reached or played. It's just there to simply define where these points are. Starting at the top, I have variable 3, and this defines the vector from start to long. Now this is output as a position. Post subtract doesn't just find a vector, it finds a position. It finds a position from the origin of the robot out in the direction of the 2 points that you have labeled. I have to convert this position to a list in order to do math with it to get the unit vector, or this is exactly what normalized does. But you can't put a position in and get a unit vector. So in variable 5, I take the 6 segments of a position variable and I convert it into a list by just listing each segment individually. I then take variable 5, and I normalize it. This is the same thing as grabbing a unit vector. So now that direction from the origin of the robot out has a unit of 1. And in this case, in the robot, it's going to be 1 meter, but I want 0.12 inches, so I multiplied it by a conversion factor of meters to inches. Now that I have a direction in a specific magnitude that I want of 0.12 inches, I need a point back. So basically what post subtract outputted, I need that p variable or that point back. So how you do that is I input every segment of variable 6 back into a list, but I prefixed it with p. That turns it into a point that's a usable position now. Then from below, I grabbed start as variable 8 and short as variable 9. This just helps later on in my loop. So then beginning in the moves, I go to the start position and I jump into a loop. The loop is basically the same as the one on the stitch weld. It's just seeing how close I am to the last point, and then once I get in with a certain distance, it breaks out of the loop. But instead of getting the tool center point, I'm instead grabbing variable 8, which is the start point, but that start point is going to shift by 0.12 inches towards the long. And once it gets within a certain value, then I'm going to cut the loop. So now inside of a linear move, I'm going to call variable 9, which is the same as short, so it's going to move down to short, and then it's going to move back up to start, so it does a little down and up move. Now I'm going to add variable 8 and variable 7. Variable 7 is my incremental distance in the direction from short to long. So I added 0.12 inches to variable 8, and I add 0.12 inches to variable 9, and then I run them again. And this is what tracks it down the line until I get to long. After the long axis is reached, or it's well within distance, it breaks out and does a safety move. It just goes Z plus by 3 inches, and then the program is stopped there. To help visualize the zigzag, I've set 3 more waypoints, and I have pen and paper on the robot, and it will draw the zigzag as it goes through them. The next pattern I have is a repeating triangle. For this pattern, I'm going to add in another variable as a waypoint, and I'm going to call it the midpoint between start and short. To perform this, I'm going to instead put that midpoint in between the start and short, and I'm going to add it first. So I'm going to move to the midpoint, add in incrementally to this axis, and I'm going to move back to the short, add in incrementally to this axis, and then back to the start added. So every time it goes through it, it will make a small triangle at the top, and it will cross back flat on the back side of the triangle. So you can see here in the triangle weld, the program looks very similar. I haven't named the waypoints down here, but 3, 5, and 4 are start, short, and long. Up at the top, I've added a variable 2. This uses the interpolate function to find the midpoint between the start and the short axis. Half means just halfway between those points. Nothing is different until variable 4, where I use the variable 2 and I add 7. So I add that 0.12 increment automatically to it, and I keep 3 and 5 the same. So already I've drawn the triangle. At the move, I start at the start point, and the only difference now is I'm using the tip of the triangle to see how close I am from the end of the line. And in the loop, I start at the start point, and then I add 0.12 inches in the direction of my long axis to all 3 coordinates, and then I run to the tip of the triangle, back to the base of the triangle, which would be the short axis plus 0.12, and then back to the other side of the triangle, which would be the start plus 0.12. It loops through this until it gets close enough to the end, and then moves up 3 inches. So here I'm going to set the start point, and then the short axis, and now for the long axis. That was a little short, so I'm going to lengthen the long axis. So I won't have changed any other variable except for the long axis. It's just going to tilt in that direction a little bit. Okay, for my final program, I call it a circular move. This is the same setup as the triangular pattern, except that the moves are now done inside of a move P, and midpoint and short side are inside of a circular move. This affects the pattern by instead making a triangle, and instead it is a constant circular arc. So it looks like this. So you can see this code is the exact same as the triangular move, except that instead of a move L here, I changed it to a move P, and waypoints 4 and 9 are inside of a circle move. Deeper into this, I will show you that move P is set up with a 0.1 blend radius. I set it as low as I could go. I think I even set it to 0.05, but as soon as you hit the check mark, it goes to 0.1. This affects how tight that weld can be. If it's less than 0.1, it'll air out. Then you'll have to come in here and make that blend radius smaller. So the lines on these were a little different, but that's because the pin is not perfectly located, just for example. So I had fun making these. It was the first time I really had to dive into the UR script manual to figure out how to manipulate and get some of the things that I wanted out of the robot. Welding is really the only industry that I know of that manipulates vectors in this way, between 2 points to get a certain action. I'm sure there's other uses for it out there. I just wanted to show how I thought that Smooth Tool programmed their stuff and how I would do it. By the way, any of these can be performed in 3D. Because there is 3 points on the ones that are 2-directional, it sets up its own plane and they can be performed in 3D. I did all these on a flat surface. It doesn't matter if it was sideways climbing up an arc, as long as it's a straight line. Smooth Tool, however, has some stuff that I've seen where they go around arcs. This couldn't do that. I hope you learned something. I know I did, and if you have any questions, let me know.